GenAI and MLOps Part 33. This episode has 13 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Describe an end-to-end MLOps architecture. Here's a strong way to approach it. An end-to-end MLOps architecture is a complete framework that automates and manages the entire machine learning life cycle from data ingestion to model monitoring and retraining in production. The goal is to build scalable, reliable, reproducible, and continuously improving ML systems using DevOps and data engineering practices. 1. Data ingestion layer. This layer collects data from multiple sources such as databases, APIs, IoT devices, logs, streaming platforms, common tools, Apache Kafka, Apache Spark, AWS Glue. 2. Data storage layer stores raw and processed data in centralized repositories. Storage types: data lakes, data warehouses, object storage, common platforms, Amazon Web Services, S3, Google Cloud, Cloud Storage, Microsoft Azure Data Lake. 3. Data processing and feature engineering performs. Data cleaning, transformation, validation, feature generation. Features are stored in a feature store for reuse. Tools: Apache Spark, Feast, dbt. 4. Model training layer responsible for experimentation, distributed training, hyperparameter tuning, model evaluation tools, TensorFlow, PyTorch, MLflow, Kubeflow. 5. Experiment tracking and metadata management. Tracks, parameters, metrics, dataset versions, model lineage, artifacts, tools, MLflow, weights and biases. 6. CI/CD or CT pipeline automates code testing, model validation, deployment, continuous training tools, Jenkins, GitHub Actions, GitLab. CI/CD. 7. Model registry stores and manages model versions and life cycle stages. Features, versioning, approval, workflows, rollback support tools, MLflow model registry. 8. Model packaging and deployment. Models are containerized and deployed to scalable serving infrastructure. Deployment methods: real-time inference, batch inference, streaming inference, edge deployment tools, Docker, Kubernetes, Kserve, Seldon. Core. 9. Monitoring and observability monitors. Accuracy, drift, latency, infrastructure metrics, feature freshness tools, Prometheus, Grafana, Evidently AI. 10. Automated retraining and feedback loop, production monitoring, triggers, retraining, validation, redeployment. This enables continuous improvement of models. Infrastructure layer. The entire architecture usually runs on scalable cloud-native infrastructure. Infrastructure components: containers, Kubernetes clusters, GPU or TPU scheduling infrastructure as code tools, Terraform, Ansible, Helm. Security and governance layer includes RBAC, secrets management, data governance, responsible AI compliance monitoring, end-to-end flow, data processing, feature engineering, training, tracking, registry, deployment, monitoring, retraining. From an interview perspective, a strong MLOps architecture focuses on automation, scalability, reproducibility, monitoring, governance, and continuous delivery of ML systems in production. Nice. Let's continue. Question 2. How would you design an end-to-end ML pipeline on GCP? Here's a strong way to approach it. Start with data ingestion into cloud storage or BigQuery. Validate data quality. Transform features using Dataflow or BigQuery. Train models using Vertex AI training. Track metadata. Register the model. Deploy to Vertex AI endpoint or GKE, and monitor predictions. Add CI/CD, approval gates, data validation, drift checks, rollback, IAM, and cost controls. A strong answer covers both ML quality and production reliability. Great. Moving on. Question 3. Scenario: a data science team wants to move notebook experiments into production on Vertex AI. What would you do? Here's a strong way to approach it. Convert notebook logic into version-controlled Python modules. Package dependencies. Create reproducible training jobs. Define pipeline steps. And track parameters, datasets, metrics, and artifacts. Then add model registry approval, automated tests, deployment gates, and monitoring. The goal is to move from manual experimentation to repeatable and auditable MLOps. Alright, next question. Question 4. What is Vertex AI pipelines? Here's a strong way to approach it. Vertex AI Pipelines is a managed service for orchestrating ML workflows using pipeline components. It helps automate steps such as data pre-processing, training, evaluation, model registration, and deployment. It improves reproducibility because each run captures metadata, inputs, outputs, and execution history. Let's keep going. Question 5. How do you decide between Vertex AI, GKE, and Cloud Run for model serving? Here's a strong way to approach it. Use Vertex AI endpoints when you want managed model deployment, autoscaling, versioning, and model monitoring. Use GKE when you need custom serving frameworks, GPUs, sidecars, service mesh, or deeper platform control. Use Cloud Run for lightweight stateless inference services with simple scaling and low operations overhead. On to the next one. Question 6. Scenario: A Vertex AI endpoint has high latency during peak traffic. How would you troubleshoot it? Here's a strong way to approach it. Check request volume, page 95 or page 99 latency, auto-scaling behavior, model size, machine type, CPU or GPU utilization, prediction payload size, cold starts, dependency calls, and regional placement. Also compare online prediction latency with model execution time. Fixes may include larger machines, minimum replicas, optimized model format, batching, caching, or collocating dependencies. Good. Here's another one. Question 7. What is model monitoring in Vertex AI? Here's a strong way to approach it. Model monitoring tracks production model behavior such as feature drift, prediction drift, skew, and data quality changes. It helps detect when model performance may degrade after deployment. It should be combined with service metrics like latency, error rate, throughput, and resource usage. Nice. Let's continue. Question 8. Scenario: Vertex AI model monitoring detects feature drift. What actions would you take? Here's a strong way to approach it. First, verify whether the drift is real by checking upstream data pipelines, schema changes, missing values, and business context. Then assess impact on model quality using labels or delayed ground truth if available. Depending on severity, trigger retraining, roll back to a previous model, fix the data pipeline, or adjust monitoring thresholds. Great. Moving on. Question 9. What is training serving skew? Here's a strong way to approach it. Training serving skew happens when features used during training are calculated differently from features used during online prediction. This can cause production model performance to drop even if offline evaluation was strong. Prevent it with shared feature logic, feature stores, data validation, and tests comparing offline and online feature values. Alright, next question. Question 10. How would you use BigQuery for ML workflows? Here's a strong way to approach it. BigQuery can store training data, run feature engineering SQL, perform analytics, and train some models using BigQuery ML. It is useful for large-scale tabular datasets and reproducible feature queries. For production, manage cost with partitioning, clustering, query review, labels, and scheduled pipelines. Let's keep going. Question 11. What is BigQuery ML? Here's a strong way to approach it. BigQuery ML lets teams create and run machine learning models directly inside BigQuery using SQL. It is useful for teams that already work heavily in BigQuery and need models such as regression, classification, forecasting, clustering, or anomaly detection. It reduces data movement but may not replace custom training for complex deep learning workloads. On to the next one. Question 12. Scenario: A BigQuery ML training query becomes expensive. How would you optimize it? Here's a strong way to approach it. Check scanned bytes, partitions, clustering, select columns, joins, repeated retraining, and whether intermediate tables can be materialized. Use dry runs, query plans, labels, reservations or slots where appropriate, and scheduled training windows. Also confirm the business value justifies the training frequency. Good. Here's another one. Question 13. How do you secure ML workloads on GCP? Here's a strong way to approach it. Use least privilege IAM, service accounts per pipeline or workload, VPC service controls for sensitive data, CMEK where required, private endpoints, audit logs, secret management, and controlled access to datasets and model artifacts. Avoid broad roles and long-lived keys. Also secure containers, dependencies, and CI or CD pipelines. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.